This video is about the derivative of a composite function. Basically, what you have first of all is let's say y, which is a function of u. It's a differentiable function of u. But this u, which acts as an input for this function f, is itself a function. So I'll say u is itself a function of x. Let's say g of x, differentiable function of x. So you realize that y becomes a composite function of x. So because if I were to replace this u with g of x, then this y would become y is equals to f of u, but u is itself g of x, so it would become f of g of x. So you realize that y is a composite function of x, and yeah, since it's a function of x, I can talk about it's a derivative with respect to x. And then this is the result. This is the chain rule, the very famous chain rule, to find the derivative of a composite function. So here I have the function y, which I am taking the derivative of with respect to x. So it is dy by dx. Remember, y is the composite function of x. And then the chain rule says that what you do is you find the derivative of y with respect to its input, which is just u. So it is just dy by du. You can find this using your definition of uh, y, which is just y is equals to f of u. So here y is solely a function of u. It's a differentiable function. So you can say its derivative exists. So you call this dy by du. You use this for to find this, and then you multiply it with the derivative of u with respect to x, and then to find this you can use the other definition. So in the other definition you have u as a function of x, and so if you find the derivative of u with respect to x, you will get this part, and then you finally multiply both the two things to get a final expression which is in terms of x, and that is the derivative of y with respect to x. So that was kind of the technical way to say the chain rule. I'll demonstrate that with an example. Here I have y as a function of x, which is just y is equals to 5 raised to this expression x plus log x. Now this can be interpreted as a composite function, because if I were to write this as something like y is equals to 5 raised to, now this expression, if I were to just ignore that and call it u, if I call this u, this is just 5 raised to u. So if I say this u is nothing but this exponent x plus log x, then my y becomes just a simple standard function of u. So this is just an exponent function. It's 5 raised to u, and in itself u then becomes a standard function, or at least sum of two standard functions. It's x and log x. So I can use this chain rule to find the derivative of y with respect to x. So if I were to find the derivative of y with respect to x, I would first require the derivative of y with respect to u. And here, as I have mentioned that y is equals to 5 raised to u, I can say that sorry, dy by du, basically the derivative of y with respect to u is nothing but the derivative of 5 raised to u with respect to u, of course, not x. Sorry. And yeah, this is just a refresher for derivative of a standard function. This is of the form a raised to u and a raised to x, basically. So its derivative with respect to u will be just 5 raised to u into log 5. If you feel confused about where this comes from, just refer the previous video on derivative of standard functions. It basically comes from that. So this is the derivative of y with respect to u, and then I need to find the derivative of u with respect to x. So if I were to do it over here, I would need to find derivative of u with respect to x. And yeah, of course, u is a function of x. I have here u as x plus log x. So I can say this is nothing but the derivative of this sum of two functions. Using rules of differentiation, I can say that the derivative of the sum is a sum of the derivatives. So I can call this as a derivative of just x, and plus derivative of this expression, which is log x. So again, kind of a refresher. Derivative of x is just 1. If you feel if you don't know where this comes from, just refer the previous video. And derivative of log x is 1 by x. Again, derivative of a standard function. So yeah, this is completely in terms of x, and we have found the derivative of u with respect to x. So now I just need to combine everything. So if I were to write the final answer, it would be dy by dx is equals to, first I need the derivative of y with respect to u, which I found to be 5 raised to u. If I were to write over here, 5 raised to u into log 5, and then I multiply it with the derivative of u with respect to x. Now derivative of u with respect to x is this expression. So if I were to simply multiply it, it's 1 plus 1 by x. Now we are almost done. The reason this is not a good result is because this is not in completely in terms of x. I expect my derivative of y with respect to x in terms of x, and if you look carefully, there's a u lying in between. So we need not worry much about it, because we know what u is in terms of x. U is simply x plus log x. So if I were to simply substitute it over here, this would become 5 raised to u is nothing but x plus log x, and then everything else is at least in terms of x, so I can leave that as is. So yeah, 1 plus 1 by x, and now this is completely in terms of x, so I can say this is the derivative of y with respect to x. So yeah, we started with a composite function. Here y was a composite function of x. It was 5 raised to u, where u was this exponent, indeed a function of x. So we found the derivative of y with respect to u first, then we found the derivative of u with respect to x, and then we simply multiplied it together. That's what the chain rule says.